Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Welcome and thank you for attending G2 Integrated Solutions webinar, Using Insights for ArcGIS to Explore and Understand Risk Analysis Results. My name is Marissa Davis. I'm Marketing Specialist here at G2, and I'll be facilitating this morning's presentation. We do have a very large group today and a lot to cover, folks, so we'll be answering questions at the end of the webinar. At any point during the presentation, if you have any questions, please just go ahead and submit them through the question box there at the side of your screen, and Tracy will be happy to answer them. Also, we'll have a couple anonymous poll questions throughout the presentation today, and we encourage you to participate in these interactive polls as they will help to guide our discussion throughout the webinar. The host of today's webinar, G2 Integrated Solutions, delivers expertise to pipeline operators, utility companies, and other energy stakeholders in 7 specialized service disciplines. We provide end-to-end solutions that help manage risk, assure compliance, and optimize performance. Our commitment is to implement innovative, cost-effective solutions that align specifically with our customers' needs. For more details on our services, please visit our website at www.g2-is.com. Now I'd like to introduce you to our presenter, Tracy Thorleifson. Tracy serves as a technical authority of geospatial systems here at G2. He has an extensive background in petroleum and pipeline industry data, business process, and physical process modeling. He is a founding member of the Pipeline Open Data Standard PODS organization and has served PODS in various roles. In his current role at G2-IS, Tracy leads a diverse team of geospatial specialists and manages GIS projects and initiatives. At this point, I'd like to turn the presentation over to you, Tracy.
Thanks, Marissa. So, we've already talked a little bit about introductions, and I'd like to introduce you all to today's topic, which is really talking about the use of Insights for ArcGIS, which is an ESRI app for analyzing data. And we'll talk about a variety of things. First, we're going to talk about pipeline risk analysis. That's the data set that we're going to look at today. And recognizing that some of you may not be integrity engineers for pipeline companies, we'll talk a little bit about the different flavors of risk analysis that are out there and the one that we're actually using for the purposes of our discussion today. And then we'll talk a little bit about why we decided to go ahead and investigate using Insights for ArcGIS as a data exploration tool. And we'll talk about how it compares to some of the traditional methods that we've used to analyze risk results. We'll spend just a little bit of time talking about the actual process of publishing from ArcGIS for desktop to ArcGIS Online if you want to make use of something like Insights. And then we'll actually jump in and we'll play with it a little bit. So we'll go ahead and take a look at a sanitized risk data set and see how we can explore it using Insights. And then finally, we'll close up with some lessons learned and some next steps as far as G2 is concerned. And we'll also talk about our wish list for things that we would like our friends at ESRI to add to Insights. So first, let's talk a little bit about pipeline risk analysis. And one thing that we all need to understand is that risk analysis is really a critical factor in terms of operating pipeline assets safely, or really any kind of assets. We're talking about risk analysis in the context of pipelines today, but one thing to understand is that G2 has a wider market base than just pipelines, and it turns out that in almost all commercial activities that are going on using rotating or reciprocating equipment, risk analysis is actually a very important thing. With respect to pipeline analysis, we use it primarily for 2 things. First, if we can understand the threats that are potentially going to have action on our pipelines, then we can go ahead and we can craft preventive or mitigative measures to counteract those threats. And then secondarily, depending on the threat type, we can go ahead and we can choose assessment methods, ways of inspecting our pipeline assets to address those specific threats. So from an operational standpoint, understanding the threats and the overall risk on your pipeline is actually quite important. Now, in terms of the way that we do pipeline risk analysis, really since 2002, there's actually been a regulatory requirement to perform risk analysis on pipelines, and really that first kicked into gear in a big way in 2004, when at that point in time, 50% of your lines had to have some kind of baseline assessment and integrity management program in place. It affects both liquids and gas pipelines, so you'll see the different sections of the code there listed in terms of the actual code that governs the use of these risk models. Now, in terms of the pipeline risk model logic itself, we do it in the pipeline industry, and actually in most industries, according to defined standards. So in the pipeline world, the overall governing document at this point in time is API Recommended Practice number 1173, which talks about the institution of pipeline safety management systems and incorporates by reference the ASME P31-8S segment for natural gas pipelines and API 1160 for hazardous liquids pipelines. And really 31-8S has been around for many, many years and has really guided the way that we approach pipeline risk analysis. Now, there are a variety of different types of pipeline risk algorithms out there, and the one that we're going to be talking about today, or using as an example, is a semi-quantitative risk algorithm that's actually a product of Kent Muhlbauer, who's one of the godfathers of pipeline risk in the industry. I'm sure many of you have read his books or at least familiar with his name. And while Kent's model adopts certain specific approaches to analyzing risk, really there's a couple of things that you'll find that are almost common to all risk models. So if we look at overall pipeline risk, what we'll see is that it's actually contributed to by two major components. The first of these is probability of failure. It's the likelihood that an event might occur on your pipeline asset. And then the second major piece is consequence of failure. In other words, if I have an event, how bad is it going to be with respect to affecting things around the pipeline? Now, in terms of probability of failure, there are really two different broad categories of failure mechanisms that we look at. The first of these are what we call time-independent threats. And these are things that don't really change as a function of time. So for instance, the likelihood that somebody is going to dig up my pipeline with a backhoe, as the little picture indicates, that threat is likely to remain constant over time, all other things being equal. And then there are time-dependent threats. These are things that just naturally get worse over time as the pipeline asset ages. These would include things like external or internal corrosion. On the consequence side of it, we have the notion of sensitive receptors. And we think of it, we use the terminology high consequence areas for both liquid and gas pipelines. And the idea here is that based on the type of product that we're carrying in the pipeline, the amount of product, and the likelihood of that product dispersing, how badly could it affect a given hazard zone. Now, also important as a consequence of failure is the cost of the service interruption. So when your gas goes off in the middle of winter in Montana, that's a bad thing. And so there's a very real cost associated with that. Now, there are a variety of different risk models that are out there in use. Some of them are what we call relative risk models that really just create dimensionless numbers for probability of failure and consequence of failure and give you a relative index scale that you can use to compare assets to one another, but it doesn't necessarily give you hard numbers. The Muhlbauer model is an evolutionary step beyond that, and while there are still a variety of subjective inputs into the model, it's actually trying to calculate a quantitative total risk value at the end of the day. And the way that it's set up is that probability of failure is expressed in hard numbers, and the units of those numbers are events per year. So it's basically the frequency of failure along the pipeline. And you'll see in subsequent slides that we switch from POF to FOF for frequency of failure. And then on the cost of failure, we're really looking at dollars per incident, trying to get to a cost per incident value. And when we combine those two things together for total risk, what we end up with is a measure that gives us values in terms of, excuse me, dollar cost per line mile per year. Right now, the nice thing about having things expressed in terms of dollars is that while it still allows me to do comparisons between one pipeline and another, it also allows me to do comparisons to unlike assets. So if I want to compare risk on my pipeline asset relative to my storage tanks or my underground storage facilities, if I'm a natural gas operator, then I actually have a basis for doing that. The second thing that makes this approach superior is that it allows you to go ahead and get some kind of an idea of the absolute total dollar amount that you should be spending to mitigate a particular risk at a particular section of the pipeline, because you're actually able to work in dollar terms. Right now, fully quantitative risk models aren't really prevalent so far to any great extent in the pipeline industry, but we see it in the reciprocating and rotating equipment world in things like drilling platforms and whatnot, and they've been around for quite a few years. I'm sure many of you have seen the IBM commercial where Watson predicts that the elevator is going to need repair by next Tuesday, and that's an example of a fully quantitative risk model that's actually predicting time to failure for a particular asset. So that's where we're trying to head with all of this. Right, and so that kind of takes us to our first poll question. And one of the things that we're kind of keenly interested in is what types of risk models are people using out there in the industry. And so the answers here to select from are, hey, are you using a fully quantitative risk model where there is no objective input? Are you using a semi-quantitative risk model similar to the Mulbauer model that we're looking at here? Or are you using an index-based model? What we would, Kiefner is the standard model for that in the pipeline world. Or, last but not least, are you still kind of evaluating risk subjectively? In other words, you don't actually have a computerized model. So we'll give a few minutes for folks to go ahead and respond to that, and then we'll move on from there. Okay, great, thanks. Looks like most of you have responded, and it looks like actually a fairly even split across the numbers there. So when we see that a quarter of you are actually using fully quantitative risk models, so that's very cool, and we're split out across the rest of the board. It would look as though we've actually got a tie between an index-based model and a non-computerized subjective model. So about 60% of you guys are still in that realm, all right? So let's talk for just a couple of moments about how we've traditionally looked at risk results and try to understand what's going on with them. Now, one of the things I didn't mention as I was talking about the different types of risk models is that these risk models can become very, very complex. So we have 8 different threat categories that we're looking at. And of course, depending on the type of asset you're operating, understanding consequence can be a complicated thing as well. And so oftentimes we end up with risk models that have dozens, if not up to 100 or so variables contributing to that overall risk number. And so you're presented with a final risk number. Trying to understand what's driving that risk is actually pretty challenging in some instances, actually in most instances. So traditionally, we've used things like risk alignment sheets or custom data viewers to look at risk analysis results. And you see a couple of examples of these here. Over here on the right-hand side is a risk analysis sheet alignment sheet produced by G2's Turbo Route program. And what you're seeing across the top are different bands showing different threat categories, the probability of failure for different threat categories. And then down here on the bottom, the consequence of failure, along with a plot of the pipeline on the map. This one happens to be a liquids pipeline. And then down here on the bottom, you'll see elevation and total volume released as well. Now, these have been great tools for looking at risk over the years, but the weakness with respect to these things is that if you have something that you missed that you might want to go look at, then you have to go ahead and go back and adjust your template, regenerate that sheet, and see if your idea is telling you what you think it is. So it's a static sort of thing, and the turnaround time in terms of playing what-if games is actually quite long. So it's not exactly an ideal tool. Now, we can juxtapose those against risk viewer applications, and this one that we're looking at here happens to be a screenshot from G2's risk viewer application. And these are great tools. They generally allow you to drill down into the results for an individual risk model. And you can actually see that going on over here in the lower right-hand corner of this thing. But the problem with these guys is that they typically have very limited integration with your GIS. So if there's some data set that you want to see on the map, that isn't actually part of the way your risk viewer is set up, you're generally out of luck. So while they're less static than an alignment sheet, they're generally still not as flexible as we would want them to be. And so that's really what takes us to insights for ArcGIS Online. Now, in my professional career, I've been blessed to play with tools like Tableau or Spotfire, which are tools that have been used widely across our industry to play with complex data sets. And Insights is actually ESRI's kind of spatially oriented version of one of those types of data exploration tools. Now, until relatively recently, Insights for ArcGIS Online was really available only on the full on-premises ArcGIS Enterprise platform. So you had to have Portal running, and likely you had to have ArcGIS for Server running as well, or ArcSDE to allow you to get your data sets. So really a pretty sizable investment in terms of software in order for you to be able to access that stuff. Well, in December of last year, so just a few short months ago, ArcGIS was released. ArcGIS Insights was released for the first time in the ArcGIS Online environment. This is ESRI's cloud-hosted mapping environment, and it's a low-cost platform that allows you to get at your data. And of course, it's entirely cloud-based, so you don't actually have to have any of the heavy iron sitting on premises to be able to manage your data. Now, the neat thing about it is that not only was Insights made available in ArcGIS Online, it also incorporates the next generation of web graphics. So some of you may be using the current map viewer in the ESRI environment with ArcGIS Online, which is based on SVG graphics. These newer tools, or the new generation tools, are based on WebGL. And it's supposed to be far more performant. And so when Insights came out, we wanted to find out if it really was. The second thing that made Insights attractive to us is that actually a little bit earlier with the 2.0 release, Insights added scatter plots to the types of graph displays that were available inside of Insights. And so that actually allows us to go ahead and create some very interesting plots with respect to digging into risk results, and we'll see those in a few minutes. So those two things combined really kind of pushed us to say, hey, let's check out what's going on and let's see how this stuff actually works. Now, to get data to ArcGIS Online, it's really a pretty simple process. You'll start with your risk results, and those are typically going to be what we would call dynamically segmented results. So you'll have a risk segment anytime any one of the inputs into that risk algorithm changes along your pipeline. And in terms of using it with ESRI technology, we're really treating those as linear events. And so what we're doing is we're attaching a route identifier to that data, as well as from and to measure stations, and posting the data in that fashion as a route event. Now, it doesn't really matter where that tabular data is coming from. I think, as many of you are aware, ESRI and ArcMap don't really care whether it's coming from a spreadsheet, a DBF file, a comma separated value file, an Oracle table. Doesn't really matter as long as it has those minimal data requirements. Once we've got it in to ArcMap, then we can very simply just go ahead and publish to ArcGIS Online as a hosted feature layer. Now, there are several different ways that you can publish data ArcGIS Online, but the important thing here to understand is that we actually went to post that data as features. So make sure that when you're doing that, you check the feature access enabled checkbox. And then at that point, it's ready to consume. Now, one thing to be aware of is that Insights is a premium app, so it's not just a freebie that's available to anybody with a level 2 named user license in ArcGIS Online. You do have to have some separate licensing for it, just as you do for, say, for instance, ArcGIS Pro. So understand that it is a named user driven app, right? So let's go ahead, before we dive into the demo, let's talk a little bit about the ESRI platform and how folks are using it. And one of the things that we're kind of interested in is to what extent people are using on-premises solutions versus actually making use of ArcGIS Online. And so the first response there is, hey, are you using what ESRI would call a complete hybrid implementation of the platform, where I've got all of the enterprise components, including SDE, server, and portal. And oh, by the way, I've also got an ArcGIS Online organizational subscription federated with that whole thing. All right, so that's answer A. Second one here is, hey, am I just using the platform on premises? In other words, I've got all of the ArcGIS enterprise components, SDE, server, and portal, but I'm not actually using ArcGIS Online, perhaps because I don't want to expose anything beyond my firewall. C, hey, I'm using the platform, but I'm not using it fully. So I'm going to have, for instance, ArcSDE, the database engine. I'm going to have ArcGIS server, but I'm not using portal. I don't have named users, and I'm using all of this with ArcSDE, but maybe I have ArcGIS Online or AGOL. And then finally, the last one here is, hey, I'm really just using desktop only. So that's the final choice there. So we'll go ahead and wait to see what kind of responses we get on that and see how people are coming along there. So as the results are coming in here, it's actually starting to look like most of you have a full hybrid implementation, which is actually pretty cool. Give it just a minute there. Yeah, so there's our results coming in there, and so it looks like for the group that we have with us today, many of you are actually using the full platform, what we would call the full platform, which is basically all of the ArcGIS enterprise components as well as ArcGIS Online. And then we've got a kind of a split between those of you who have only on-premises and those of you who are using some combination of the on-premises platform stack plus ArcGIS Online, which is pretty cool. It looks like very few of you are actually using only a client-server implementation and the web-based GIS. So that's actually kind of cool. It suggests to us that the uptake of the technology is actually very good in this group that we've got online. So with that, let's go ahead and actually jump into a quick demonstration of it. So let me go ahead and switch from presentation mode here, and we'll go ahead and dive into Insights for ArcGIS. Now, I've already gone ahead and logged into the example that we're going to be looking at today. And this is a data set that actually comes from one of our clients. we've obfuscated the actual risk results themselves a little bit. So the numbers don't mean a whole lot in particular in terms of absolute values. But other than that, it's actually a fairly complete data set. So what you'll see over here on the left-hand side is that I've got my tabular listing of data. And one thing that I want to point out right after the bat is that I've gone ahead and I've converted my linear risk segments to points. And so while I am carrying begin and end measure for these records, if we scroll down here to the bottom, what you'll see is I've added a measure value as well, which just happens to be the midpoint measure between the begin and the end station. This is a fairly large data set that we're looking at. So for this collection of assets, we've got a little bit over 60,000 records present in the data set. And again, it's all hosted online. And what I've done is I filtered by line ID. So we're only looking at a single line's worth of data. And this particular line has a little bit over 4,000 risk segments on it. So it's a fairly dense set of points. And for those of you who have played with this kind of data in the web map viewer, 4,000 points would completely overwhelm the existing web map viewer. So already we're seeing that we've got some performance enhancements over the traditional stuff. Now, in terms of what we're looking at here in our plots, we've got a variety of different profile plots. And so you'll see here, this guy on the lower right is an overall total risk profile. And the way these profile plots work is that we have on our x-axis measure along the pipeline asset. In this case, for this line going from 0 to somewhat over 600,000 feet, on our map, just to kind of orient you, the 0 point is up here in the northeast corner, and the 600,000 plus point is down here in the southwest corner. So the trend of the pipeline stationing on the map is actually opposite to the overall profile plots. Now, when I look at risk results, one of the first things that I want to understand is the distribution of risk values, either on a single pipeline or throughout my entire data set. And so creating a risk histogram, which is this plot that we see here, is actually an important aspect to understand what's going on with risk on the pipeline. And really what I'm looking for is what kind of distribution do I have? We can see here that we've got a fairly normal distribution. And of course, it's this long tail of higher risk values that are of interest to us. Because if we can go ahead and we can address that long tail of values, then we can significantly reduce the risk hotspots on the overall pipeline, right? And if I go down and I look at my risk profile for this line, and again, we're looking at total risk here, what I immediately see is, hey, we've got some outliers up here, right? So I've got some values on this plot that are, kind of well above the background in terms of the way this data set's oriented. So I'm going to go ahead and I'll activate my selection tools, and I'll just do a box selection, and let's go ahead and select those points. All right. So what you'll see is, as I make that selection, is that those points are highlighted on this profile plot, and what's going on in the background is that those same points are being highlighted across all of the other points in my insights template. Values that are selected on one plot are immediately updated on all plots, right? So I can see over here that my points are highlighted. We'll go ahead and zoom in there and kind of look at what's going on in a little bit. On my risk histogram, I can't really see it because the bar is so low, but those guys are highlighted as well. And if I go ahead and first break down total risk into my two main risk components, frequency of failure and consequence of failure, what I see is that for those points, they are both high in consequence of failure and high in frequency of failure. Now, that's not necessarily always the case, but it certainly makes sense in this instance, since those guys are highest in overall risk. And of course, we get the same message if we look at our frequency of failure profile and our consequence of failure profile. So these guys are high consequence of failure points, and they're also high frequency of failure points. So we're kind of getting a double whammy there. Now, in practice, there's not a lot we can do about consequence of failure. We can go ahead and we can reduce the operating pressure of the line, but we generally don't want to do that. Or we can physically move the line to get it out of the way of sensitive receptors. But those are big projects, right? So what we really want to concentrate on is understanding our threats of concern. And if we can understand which of the threats are actively putting this asset at risk, and can mitigate those threats, then we can significantly impact overall risk on the pipeline. So if we dig in a little bit and look at external corrosion first, what we see is that, hey, those points in terms of external corrosion are actually quite low. So external corrosion is not an issue for us. Same thing for internal corrosion. We're actually down on a lower risk segment of the pipeline with respect to internal corrosion. If we go ahead and we look at stress corrosion cracking, which is due to cyclical stress on the pipeline, what we see again is we're way low there. So stress corrosion cracking is not an issue for us. If we look at geohazards, these are things like flood scour or slope creep or earthquake risk, that kind of thing. Again, what we see is, hey, while there are some elevated points on the line, it's not an issue for these segments, so not a threat of concern. However, if we come down and we look at third-party damage, the likelihood that these segments are going to be exposed to damage, what we see is, yeah, hey, we've got an elevated risk of third-party damage. Same thing with respect to sabotage. So we've got an elevated risk of sabotage, and these kind of things they often tend to go hand in hand. So it's not unsurprising to see that. And then finally, we see that we're at elevated risk for incorrect operations. So if somebody makes a mistake in the control room, we're going to have an issue here. So those three things are actually our threats of our concern, and we're able to figure that out almost instantaneously in terms of just being able to create a few quick plots and view that information inside of Insights. Now, if we come back over to our map and we activate the map, let's go ahead and let's zoom in to our area where we've got these points. And what you'll see here, let me zoom out just a little bit. Is that, well, boy, howdy, look at that. We've actually got above ground assets right here. We're right next to a major road. And so, the likelihood of having this asset impacted by people in this area, people doing things like excavating, is actually pretty high. We look right over here, that's actually a control room facility or a pipeline facility. So again, this notion that hey, we're going to have an issue in terms of incorrect operations is actually quite high too. If we zoom out a little bit further, what we see is that indeed this pipeline is actually running through a populated area. So in this particular instance, makes perfect sense. This is a part of the world that's not actually very highly populated, but what we are seeing here is that we've got people around. So if we do have an incident, we're likely to have high consequence to that failure. So things are kind of hanging together in terms of how the map is working. Now, the really cool thing about this is that I can go ahead and I can add additional plots and cards at my whim. I can also go ahead and pull in data from everything that's available in ArcGIS Online, so I can bring in landscape layers, so I can pull in additional information to put all of this information in spatial context, as well as, of course, my pipeline asset information itself, so I can go ahead and pull in my fittings and my pipe segment features and all that good kind of stuff. So what I'm able to do in this environment very flexibly is to very quickly dive deep into the data and get a real good feel for what's going on with it. And so that's actually a very nice outcome in terms of working with Insights here. Now let's go ahead and we'll pop back into presentation mode and wrap up here. So let's talk about lessons learned and where we go from here. So one of the neat things about this, and actually I was pleasantly surprised as we started to dive into this, is that insights in the ArcGIS Online environment is actually quite performant. Right, so we can throw reasonably large data sets at it, and it doesn't even care. It's perfectly happy with that. So that's very handy. For those of you who've worked with ArcGIS Online, one of the neat things about it is it's just super convenient and very flexible in terms of being able to put data up there. And last but not least, if you do have the full on-premises stack and you federate things together, ArcGIS Online just becomes an extension of your on-premises stack. So it's fully integrated into the full platform, which also makes it very nice to use. Now, having said all of those very nice things, there are of course things that we would still like to see added, and so we're actually interacting with our friends at ESRI that kind of get these things on the list. One of the things that would be nice to have is actually to be able to do line graphs. So the dot scatter plots are nice, but we're used to looking at these things in terms of line graphs, and it would be nice to have that. A second thing that would be very handy to have is to actually be able to go ahead and plot multiple graphs on the same plot. So I've got a common x-axis on all these scatter plots, it's measure. And in many of the cases, I could actually go ahead and reasonably add multiple variables to the same plot and still have things scale nicely and make a nice looking display. So it would be nice to have that. And then finally, the pie charts and the bar charts that are in Insights at the moment, they're really kind of geared towards traditional data exploration tools. So if we were to dig into the options for those, you'd say, hey, that looks kind of like Excel or Tableau or Spotfire. And what we're forgetting here, what Esri's forgetting here, is that, hey, we're actually looking at spatial data. So instead of having to plot a pie chart or a bar chart based on some sort of grouping attribute, a series attribute, if you will, why not just do it spatially? So use the selected features or use the features that are visible on the map. And then last but not least, even with the grouping by attribute that we have now for these plots, I can only group by character attributes. So if I have a discrete small set of numeric integer values, I can't use those as a grouping mechanism. So a couple of things that we'd like to see added there. Right, so that pretty much wraps up what I wanted to show to you all today. We're just a little bit over time. Be happy to entertain any questions that we might have. Marissa?
All right, if you have any questions, go ahead and enter them now in this question box. It looks like we've got one. It says, Tracy mentioned the model was semi-quantitative. Does the model take a qualitative approach as well? And how cohesive does data need to be to support the qualitative approach?
So that's actually a great question. And if you ever are lucky enough to attend one of Kent Mulbauer's seminars or have him come talk to you, basically what he'll tell you is that the way to think about it is that if I'm stuck putting in qualitative information, basically subject matter expert-based information, where I'm not real confident about it, the way to think about it is it doesn't make the number values that you get out invalid. It just puts larger error bars on them. Right, so you can start out with a relatively incomplete set of data, or at least what you might think of as being an incomplete set of data, and you can actually still run a Mulbauer type analysis. Right, the thing to understand there is that the numeric values that you're getting out are going to have larger error bars on them than they would if you were actually able to provide more quantitative input. Right, so that's the takeaway there.
Okay. How do you feed data to Insights? We use PFIM for relative risk rating.
So, okay, great question. So relative risk models are great too. And of course, what you're going to get there is a risk index value, right? So the way to think of it is, hey, I've actually got units attached to the Mulbauer output, whereas the numbers that you're getting out of PFIM are actually dimensionless, right? Well, the plots don't care, right? So all I have to have is my measure values and some kind of number that I can plot on my y-axis. So that's totally legit too. The key thing is that you do have to have some kind, if you want to go ahead and post it as route events, as I've done in this example. Obviously, you're going to want to have a route identifier and from and to measures. If you don't have that, well, that's okay, right? So much like Tableau or Spotfire, I can still do a lot of fun things with insights, even if I don't have it tied directly to a map. And so one of the things to understand there is that what I'm actually driving all of the graphs with is the numeric attributes in the table, right? So if I don't actually have those segments linked to individual dynamic segments on a map, I can still look at the data. And as you guys know, in terms of the complexity of variables with respect to the model, even that can sometimes be quite variable or valuable.
Are the calculations for the risk running on the back end of Insights, or is it previously done?
Great question. And so in this case, previously done. Now, if you were running on premises and actually had your data model hooked into ArcGIS in some form or fashion, then that link would be live, right? So in this case, what I did was I actually took a set of results and published them to ArcGIS Online. So I don't really have a good mechanism for updating those results and playing what-if games, like for instance, putting in a certain mitigation plan. I don't have that ability in ArcGIS Online very conveniently without actually updating the data. But in an on-premises environment where I've got my risk algorithm hooked into either a database table or into a geodatabase, then that's a very doable thing.
Are the begin and end measures generated on a dynamic segment level, or are they on a segment ID level?
Okay, so those are on a dynamic segment level. So each little risk segment that we have has its own begin and end measure. And again, the way to think of it is, for those in that particular data set that we were looking at, there were 93 different model variables going into it. And wherever any one of those variables changes as you're walking down the length of the line, then that causes a new segment to be created. So on that line, which is about 100 miles long, there were 4,000 plus segments.
All right, well, it looks like that's all the questions we have for today. Thanks again for attending, and we'll be sending out a copy of the presentation as well as a link to the recording after the presentation today. It'll probably be tomorrow sometime. If you think of any questions afterwards, you can go ahead and contact Tracy directly at tracy.thorleifson@g2-is.com, and I'll make sure that contact information is on the presentation when I send it. But other than that, hope you all have a great day, and we'll see you next time.
Thanks, folks.